Hey guys, alternators. Uh, Alternators are really pretty simple, and a lot of the construction is kind of the same as a starter. I mean, it's kind of built the same way. It's only got a couple of wires. There's a big fat B line, which goes to the battery. There's an S line, just like the starter. That's the sense line. There's a couple of other wires that some starters have. Some of the way they work kind of varies by platform, but it's really not that difficult. So here, let's dive in. I'm using a particular alternator. This is uh, the most common alternator in the world. It's a Japanese manufacturer. It's called a Nippon Densu, and who uses this? Everybody. Everybody uses this alternator. It is by far the most common alternator that there is. The Germans, Mercedes, Porsches, BMWs, they use it. The Americans, the Chryslers, Fords, GMs, they use it. Heck, they use it in NASCAR. They use it in the Japanese cars, the Asians cars. They are by far the most common alternator platform that there is. There's a couple of variations based on platform, manufacturer, and year, but basically they're all the same. I'm going to walk you through it. It's pretty simple. Uh, the alternator has three, or the charging system has three major components. It's the battery, the alternator, and the regulator. The alternator works together with the battery to supply the vehicle power when the engine is running. Now, battery does a great job at storing electricity, and it's able to release this electricity very quickly. However, it needs to charge at a slower rate. It can't be charged very quickly. So the alternator has to, work within these parameters. Now, also some temperature compensation in this. And honestly, the numbers are pretty straightforward, and that's virtually for every car. There's some variation based on what type of battery technology they have, whether or not it's a AGM, or whether it's just a flooded lead acid like the common one is. But it's pretty universal. The output of the alternator is direct current. However, internally it produces AC, and then it's converted to DC by the diode rectifier bridge. Uh, so that the battery can retain this. If you hit the battery with AC, it just cook it. Wouldn't work as well. So we'll talk about that too. Now, this is by far the most complicated wiring that you'll see in an alternator, and some of them are much simpler than this. And we'll look at a couple. We have this big fat B line that goes back to the battery. This is the heavy current side, and then we have the IG line, which runs through the ignition switch. So this actually just goes on and off with the key. It tells the alternator when to turn on and off. Then we have the S line, which is the sense line. And if you look where it goes, it still goes back to the battery. Now, it may, go to a separate fuse box. Usually this line is fused. And then we have the L line, which goes to the light, the charge light. And if you look at it, one side of this charged light goes to B plus and the other side goes to the alternator. So to turn this on, the alternator supplies B plus. Now, the alternator uses this L line if it has one. This is rather old technology. It supplies a ground when the alternator doesn't function, and that turns on the light. But when the alternator is working correctly, it supplies B plus, 12 volts positive on this line. And if we have positive on this side of the light bulb and positive on this side of the light bulb, it's not going to light. But if there's some low output on this line, this guy will be lower than this B plus line, this IG line, and that will cause it to come on dimly due to a voltage drop across it due to a difference in voltage. You get that part? Talk a little bit about it further on. Looking at the back of the alternator, of course, the B line is a big fat stud, and then there's a plug with a couple of wires on it. Now, there's also, on some of them, there's an F terminal, a regulator bypass to full field the alternator. And what that means is it's put into maximum output. We look at the outside of the alternator, and we have covers, and we have a split case. Generally, it splits in two. We have a drive pulley, and then we have some circulation vents. We also have mounting ears. Now, sometimes these mounting ears, you have to be very careful with them, especially when you get a replacement alternator. We have a bad alternator and we're replacing it. Here's my tip: when you take the alternator, the new alternator out of the box, match it up very, very carefully for pulley size, pulley diameter. If it's a serpentine belt, make sure it's got the right ribs on it. Some alternators don't come with a pulley, and you have to take the pulley off of the old alternator and put it onto the new alternator. And I'll show you how to do that. It's really very simple. And then we look very, very closely at the mounting ears to make sure that they're in the right orientation. And some of these guys can be off just like a millimeter or two, and it's really hard to see. So spend some time checking to make sure that it's the same alternator and it's going to fit on there. And then my other tip is don't ever let the old alternator go until the new alternator is installed and working. And here's the problem that you run into. Let's say I get the wrong alternator, or I find out after I put it in that the pulley's different and I got to get the pulley off the old alternator. Well, if I turn that in for the core at the auto parts store, they throw it in a pile. I may never see that alternator again. And, if the mounting ears are off or it's clocked wrong, which means, instead of having the B plus here, it's on the other side, which happens. I mean, the mounting ears are right, the pulley's right, but this, or the plug is slightly different because they got you the wrong gear. Man, do not let the old alternator go until you're sure it's the right one and it fits and it works. Live by that rule. All right, so the alternator contains inside, there's a rotating field winding called a rotor. It's just like the armature. It's a big, heavy piece, but instead of having several segments, it has just one wire that wraps all around. It's got a stationary induction winding called a stator. The stator surrounds the rotor. So the rotor spins inside, that's pulley driven, and that's what generates the AC voltage. And then there's another device called the diode rectifier bridge, and that's what changes the AC produced in the stator to DC B line out to the battery. And then there's some internal fans and stuff. So we look inside on the back, we can actually see that here is my voltage regulator. Not all voltage regulators are inside the alternator. As a matter of fact, newer cars, it's very, very common that this voltage regulator lives inside the PCM. Sometimes it lives inside the alternator and it's controlled by the PCM. This is the transistor, the heavy transistor that switches on and off rotor current to control alternator output. Get it? All right. So these Nippon Densus are actually really easy to repair because we pull off this rear cover. I can see the voltage regulator. Here's my brush assembly. And then here's my diode rectifier bridge. They're all right here. Now, I can buy all these pieces, and I may, if this is kind of a weird one-off, I want to make sure that the original OE alternator stays on the car, I may repair it. But the common practice today is just to replace this whole thing as a unit. But realize I can buy these parts. Go to a parts store. So here's my drive pulley, and this is either pressed or just bolted onto the shaft of the alternator. Usually there's a bearing right here, right behind it. And this particular alternator does not have an external fan. It's inside. All right, so here is my regulator. Here is my brushes. Here are my slip rings. That's what the brushes contact to, much like the commutator in the starter. Okay, so it has brushes, but it only has 2, where an alternator had 4. And then the diode rectifier bridge converts it from AC voltage to DC voltage. All right, here's my brushes. These are just carbon brushes. They're rather soft. There's 2 of them, and that's what contacts the slip ring. Okay, this allows the sliding contact of the brushes on the slip ring to keep electrical contact with the spinning rotor to maintain the electrical field. The electronic regulator. Okay, these guys are solid state. They used to be like moving part relays back in the day. Back in the day, this had to be adjusted. No longer needs to be done. Okay, the rectifier, the regulator controls current going to the spinny rotor. Rotor spins inside the stator, and it's an induced changing magnetic field that causes it to induce the voltage, the current, the AC voltage into the stator assembly. So this guy's job is to monitor the vehicle voltage, the voltage of the vehicle. And if it drops below a certain amount, it kicks up the output of the alternator to compensate. Much like when I put a heavy load on the battery, it dragged the voltage down due to the high amperage. So, I turn on the headlights, voltage drops a little bit, voltage regulator picks that up and kicks up the current of the alternator. Get it? This takes a second for it to happen. I mean, literally like a second. We're going to look at this when we go out in the lab. Okay. Regulators can be mounted both internal or external. The current external is way old. We don't use that anymore. Fords were the last ones to use it. Crazy. All right, so the diode rectifier bridge. Diode rectifier bridge is what's responsible for changing the AC current, the AC voltage coming out of the stator that surrounds the rotor. Okay, rotor spins, DC spins inside the stator assembly. Stator is stationary, rotor spins inside, the stator is AC. Okay, so the diode rectifier bridge is what changes it from AC to DC, and it's connected. You can see it right here, B-line battery. Get it? Okay. We'll talk about those in a second. So inside the alternator, here is my stator assembly, and it surrounds my rotor. Goes all the way around. There's a couple of taps on here that tap into the diode rectifier bridge. So this guy just sits there. It's 3 wires. There's 3 of them in there. Okay, there's 3 separate wires wound around and staggered around inside here.